record this so that if you need to go back and look, because I'm actually going to give you another worksheet today. I was planning on giving you one tomorrow, but since there were so many problems on these that you guys had, with the other class as well, I figured I'll just give you the worksheet tonight so you can work on it again. All right, well, let's take a look at this. This is number 19 from page 536. Let's put some numbers in there. That length is 17. This one is Z. This one is X. This is 6. And the whole thing, this whole hypotenuse from here to here is Y. Because I said so. All right.
I get it now.
Yes. All right. Let's do a few things. I tell you what. Let's change some colors. Let's make all the things that are a geometric mean. Let's make them the same color. So these are all the things that are geometric means. Everything that's in color right there. What does that mean? No. It's these three. Remember we talked about this yesterday. We called this H yesterday, didn't we? The altitude. Yeah. This is the same thing that we did yesterday, except I just took the triangle and I just rotated it, didn't I? All right. So it's just not sitting on its side right here, you know, on the base of it, or the hypotenuse, I should say. We just twisted it around. It's the same deal. So this is the altitude. This, I think, what did we call it yesterday? A and B. I think this was our A yesterday, and this was our B yesterday. You follow me? Mm-hmm. And so what did we say? We said the A, the B, and the H were all what? The geometric means. Okay, and what do we do with the geometric mean? We set up a proportion, right? Remember this? We said H was the geometric mean between this and this. Yesterday, what did we call this segment from here to here and this segment from here to here? Called it X and Y. Now look, don't relate this X and Y to this stuff right here. I'm just talking about yesterday. It's just review from yesterday. So H is the geometric mean between this segment and this segment, right? And then we said A was the geometric mean between what? The whole hypotenuse, which I think we called C yesterday, and the segment that's adjacent to this. And I believe that was X yesterday. Well, anyway, without getting too much into what we did yesterday, let's talk about the numbers that we have in front of us. And let's do this. Let's just kind of scooch this over so I have some room to work with. Let's just kind of, oopsie daisy. Let's try this again. If I could grab that. There we go. Let's just scoot it over, and then we'll do our work over here on the right-hand side. Okay? That's okay. Forget this section. Now I got to change everything back to that, and then change it to purple. Come on, where is it? There we go. Now we're where we're supposed to be. Let's do this. Let's start with here. Yesterday we started right here, and we started with the altitude as our geometric mean. What's the big difference in this problem compared to the problem that we did yesterday in class? Before, what was the geometric mean yesterday in class? H. It was H. We didn't know what it was, but say, Rachel, what's the big difference?
If we have a number for that.
Yeah, we actually have a number for H, don't we? All right? So you work with it just like you did yesterday. So you're going to look at this and you're going to say, oh, I can't believe I didn't think of that. I hope you say that. You did? So 17 is your geometric mean. Does that make any sense? Yesterday when we did this, we said H was the geometric mean. We put an H here and an H here, didn't we? Look back on your notes. I'm not getting any nods or anything. Are you guys listening? Okay. So this is your geometric mean. Well, the altitude or the height is the geometric mean between what two numbers? Between what and what? X and Y. Well, in this case, it would be what? 6 and
Y minus 6.
Y minus 6. That's right. I'll tell you what. I'll keep the geometric means purple, and let's go to a different color. Let's go to yellow. So this would be Y minus 6. Agreed? Good. So 17 is a geometric mean between what? The two segments, 6 and Y minus 6. It doesn't matter which one, you know, where you put each one, because you're going to multiply them together anyway, right? So let's do this. We'll cross multiply, don't we? So let's cross multiply. Let's do our work in another color, blue. So let's cross multiply. If I was going to multiply this together, I would get 6y minus what? 36 equals 17 times 17, right? Or 17 squared, which is, let's just write that out. What is it? 289? Everybody with me so far? Now we just solve for y. So 6y equals, add a 36 to this, and what's that? That's a 5 and a 2, or yeah, and a 3, right? And divide that by 6, and that's what y is equal to. Let's just write it. Nope, don't want it as a decimal. I want to keep it as an exact number because we're going to work with this number a little bit later, and we're going to do some stuff with it. I don't want to work with approximations. I want to work with exact numbers. You follow me?
So even if the book says don't write in decimal, you don't write in.
I don't want you writing in decimal. I don't care what the book does, okay? You do what I tell you to do, all right? So I want these answers as exact, simplified answers. You hear what I said? So when it's a square root or radical, I want it simplified. We talked about that yesterday. And just to kind of make sure I was on the right track, I talked to Mr. Jackson today earlier, and I asked him, is there really an importance for these kids to understand how to simplify radicals? And he agreed that yes, there is. Okay. Now look, when you get into physics and chemistry and stuff like that, or whenever you use square roots, there will come a point where you don't really have to simplify. You're basically just throwing everything to a calculator and getting decimal approximations. Okay. But for right now, learning the math, I want to have exact answers. I don't want approximations. I want exact answers. You okay with that? All right, so that's our exact answer. So that's what y is equal to. So that was nice. Not the prettiest answer I've seen in my life, but it's a very viable answer. Okay, it's not a problem at all. Keep it like that.
I think the only thing that I don't understand is when you're doing like which numbers to use or which sides like correspond with.
Right. Well, that's what you have to memorize. That's what you should have learned yesterday. Now, I'm not saying you should have mastered it yesterday, but I gave you plenty of information yesterday to know which, this is geometric mean between what two numbers. Look, there's only 3 of them to memorize. It's not that hard. Let's do it really quick. Watch. This is the geometric mean between the 2 segments of the hypotenuse. X is the geometric mean between what? The whole thing and what? The segment that's next to the x. So it would be what? Between y and 6. Z is the geometric mean between the whole thing and y minus 6, because this is the segment, it's not x. Okay, this is the segment of the hypotenuse. See, the whole hypotenuse is y. This is one segment of the hypotenuse. This is another segment of the hypotenuse. Do you see it? So x is the geometric mean between the whole hypotenuse and the segment that's next to the x. Z is the geometric mean between the whole hypotenuse and the segment that's next to the z. That's it. Memorize those 3. That's all you got to do.
And the altitude.
And the altitude is a geometric mean between the 2 segments themselves. That's it. Okay? That's not hard to memorize, is it? That's something that, with a little bit of time, a little bit of effort on your own, sitting there and saying, okay, it's between this and this, between this and this. You should be able to come up with that. All right, let's keep going. Let's go green. Let's do, I don't know, let's do x. X is a geometric mean, isn't it? So x is a geometric mean, so it goes right here and here. Between what and what?
6.
Between 6 and the whole the whole thing.
6.
This is the geometric mean between the whole thing, which we just found, right, which is 325 over 6. It's kind of ugly, but that's all right. It works out nice. Do you see that? So x is a geometric mean between the whole thing and the segment that's adjacent or next to that x. Yes?
That's cute.
All right. Now we just do some algebra, right? X squared equals that times that. So let's do the math. I'll do the fraction first, if you don't mind. 325 over 6 times what? 6 over 1. Wow, look how this came out. That canceled out, didn't it? Okay, so x is equal to the what? Square root of 325. Now we're not going to keep it like that, and it's not going to be about. We just had a big conversation about this like 5 minutes ago. What did I just say? We don't want approximations. I want exact, simplified answers. Okay, what's an obvious number that goes into 325? Okay, well 5 does, right? And then let's see if 25 goes into it. So punch it into a calculator. How many times does 25 go into it? 13 times. So watch. What I'm going to do, I'm going to say 25 times what? 13. Okay? Now look, that works out real nice because what's the square root of 25? 5 what? Square root of 13. Not 2 though, right? Times the square root of 13. And there's what x is. See how nice that was? And that's the answer that I want. I want you to write it like this. Don't leave it square root of 325. Don't put it into a calculator and get a decimal approximation. Okay? Your teachers in the past, Joanna, your teachers in the past have made you simplify radicals, haven't they? Yeah, because I've noticed on their papers, because I haven't made you do that before, but I think all the Korean kids, every time, and it's because this was the way they were taught. They were made to do it that way, I would guess. Is that true? Did your teachers make you simplify your radicals? Yeah. And I don't think they do that here enough, okay? And that's what I'm going to make you do. That I'm going to make you learn how to simplify the radicals. All right? So there we go. Let's do Z. Let's go back and look at the picture. What haven't we used yet?
What about invisible color? What about black?
Okay. We'll use this again. Oops. Let's go back. I brought it down so I could see it. Okay, we want to do Z. So Z is the geometric mean. So Z is the geometric mean between what and what? Between the whole thing. The whole thing. What's the whole thing? 325 over 6. And the segment that's next to Z,
Y minus 6.
which is y minus 6. Now look, let's go off to the side a little bit and actually do y minus 6. What would we say y was?
325 over 6.
Okay, minus 6. Instead of, though, writing 6 over 1, no, come on, 1 over 6 is not the same as 6 over 1. Let's think. Common denominators, thank you very much, okay, it's 36 over 6. Why did I write it like that? Because I want to subtract with a common denominator, right? Does it make sense? Yeah. It doesn't? What's
Did
30?
you say what's the same thing as 6 over 1?
Yeah, 36 over 6 is the same as 6 over 1.
Oh, yeah. Oh, yeah.
289.
Okay. 289? Okay, so that's 289 over 6, right? So it's 289 over 6. You see that? So that's what y minus 6 is equal to, 289 over 6. So you had to do a little extra work to find that. But let's keep it as fractions. Let's not make these things into decimals. Now all we got to do is just simplify this. So z squared equals, what do we have here? 325 over 6 times what? 289 over 6. Do you recognize that number 289?
Yep.
We worked with that a little bit earlier, didn't we?
Yeah.
Right there. 17 times 17 is 289. So guess what the square root of 289 is? It's 17. Okay, and we already figured out what the square root of 325 was, didn't we? Alright, so watch what, let's just do it like this. 6 times 6 is 36. So watch this. I'll tell you what, let's do it like this. What times what is 325? 25 times 13. Okay, and then
Minus.
I'll just write 289. But what are we going to do? We're going to take the square root of all this. So I take the square root of all this. This is easy. Okay, it seems like a lot of extra steps, but it's really not that big of a deal. I'm going to take this. No, there's a rule that says I can square root if everything's being multiplied or divided, I can square root each one of these individually. So it's the square root of 25 times the square root of 13 times the square root of 289 over the square root of 36. Okay, I don't have to show that step though, do I? No. So what's the square root of 25? 5. Let's do this one. What's the square root of 289? 17. What's the square root of 13? Just the square root of 13. That's the only way I can write it. Okay, it's not 13, is it? Okay, it's the square root of 13 over what?
36.
Just 6, because I'm taking the square root of 6. We're almost done. Z equals, watch, 5 times 17 is 85, what? Times the square root of 13 over 6, and that's what Z is right there. Now, if you look in the back of the book, they're writing these as decimals. I don't want you to write it as a decimal. I don't care if they do or not. I don't want you to write it as a decimal. I want you to write it like this. Now, you can always check to see if you get the same answer that they have, don't you? Or can't you? Right? Throw that into a calculator. The only reason you would throw this into a calculator is just to check to see if you got the same answer that they did. That's all. That's all. I want you to write it like this. So all three of these things that are circled, can I get them all three on the screen? Okay, all three of these that are circled right here is the way that I want you to write the answers. I want you to write it like that on a quiz. I want you to write it like that on a test. You got it? You could always throw it into a calculator just to check to see if you got the same thing that the book does. So what do you think? Is that something that you could do? I mean, look, it was definitely a little more complicated than what we did yesterday, but it was the same basic steps to begin with, wasn't it? Right? We said this was the geometric mean between what? This one and this one, right? This is the geometric mean between the whole thing and this one. Z was the geometric mean between the whole thing and this one right here. The rest is just all algebra, right? It's just all simplifying radicals and multiplying things together and all that stuff. But this is the only geometry that you had to do, was know the geometric mean and what it is between. And then you just start cross multiplying, and then it takes a little bit more algebra than when we've been doing, most of this year. But it's good preparation for you for next year, because you're going to be doing a lot of this stuff in Algebra 2 with radicals and all that good stuff. Okay? So what do you think? Do we need to do another one, or do you think that kind of gets you on track?
Well, all my
Can we do,
homework
like,
is wrong.
27 or 23?
Considering it took.
All right, we'll do a hard one.
Considering it took.
Oh, one of those?
Problem.
All right, we'll do 27. Let's do 27. And then we'll do 30, Chris. Let's use this ugly brown. Cappuccino. We haven't used that before. Looks kind of tan. Have we used it
Yeah,
before?
yes.
Yeah, somebody said it was gross or something. What do you want to do, 27 or 28? Let's do 28 since it's an even.
Let's do new lesson.
So 3 square root of 5.
Let's understand this one.
Now what's it say? It says find the what?
Geometric.
The geometric mean, I'll just shorten it, between these two numbers, between this one and this one. Okay? So, what do we do? Yeah.
No, never mind.
Do a proportion first, right? Set them up. So we want to find the geometric mean. We'll just call the geometric mean x. So where does x go? Right here and down below on the other side. You got it? Between what? This and this. So what do we do here? It's just 3 square root of 5 over 4. That goes right here. And 5 square root of 5 over 4 goes right here.
2%.
It's over 7? No. I'm doing 28.
Then why'd you write 27?
Because I was seeing if you would pay attention and see if I was doing the right one. Alright, this is 28. So let's cross multiply. So x squared equals, what do we do with these? Just multiply them together, right? So let's write it out. Multiply this times this. Let's do the bottom first. That's easy. What's that going to be? 16. Let's do the whole numbers on top. 3 times 5 is 15. Let's do the square roots. You should be able to do this in your head eventually anyway. Square root of 5 times square root of 5. It's just 5. Okay? You could go the long way. You could say square root of 5 times square root of 5 is the square root of 25. What's the square root of 25? It's just the whole number 5, isn't it? Or you could look at it like this. Watch. Anytime you take a number and multiply it by itself, aren't you squaring that number? So watch this. If I took the square root of 5, multiplied it by the square root of 5, isn't that the same thing as saying the square root of 5 what?
Squared.
Squared. What happens to that square root and that squared? They go away. What are you left with? Just a 5. You could look at it a couple different ways, couldn't you? Alright. So what's that? What's 15 times 5? 75?
Yep.
Over 16. Nothing cancels here, does it? Nope, nothing goes into anything, so that's your answer right there. I think it is. That's not what they wrote as the answer. Did I do something wrong? What did I do? Oh, I didn't square root. Thank you very much. That's not it. Right, x squared is equal to that, but x is equal to the square root of 75 over 16. So let's simplify this. I know what the square root of 16 is. It's 4, isn't it? What about the square root of 75? Let's break it down.
25 times.
Good, 25 times 3. Okay, and then, so let's take the square root of everything in here. Square root of 25 is 5, and then the square root of 3, and that's over 4. Now that's the answer that they have. That's better. Thanks, I forgot to take the square root. And that's how you do that. Getting better at these? Square roots aren't so bad, are they?
Yeah.
I mean, really, what's been hard so far about these square roots?
0.
I don't think anything. Do you? 25 times 3 is 75. Is that hard? Look, take the square root of 16. That's 4. That's not hard. Okay. The hardest one, I think, was when we did the square root of 325. That was probably the hardest one. Okay. But you know 5 goes into it, right? Yeah? So you put in 5, it's like 26, right? I think it is. Or no, it would be, I don't know.
If it ends in 25, obviously you can do.
Right, if it ends in 25, you know 25 goes into it. Okay, so you just throw in 25. I don't know what that is in my head, but you know it's 25 times 13, and you throw it into a calculator. Then it's really simple. Make sense? Good. Alrighty. Let's do, Chris, which one did you say?
30.
30? Oops, let's pick a good color. I like the blue. Cyan, actually. Alright, 30. Do I still have my triangle
Do
copied?
you like
Good.
geometry?
I love it.
Are you serious? You really like this stuff?
Why not?
Why?
I thought everybody does. I thought everybody likes it.
I just like
I like algebra.
Raise your hand if you like geometry.
Rachel,
Raise your hand. Better raise your hand. Better raise your hand.
So we have.
What does that prove? Just because you guys don't know what's good. Just because you don't know what's good.
I know Ben doesn't like it. I'm not sure about Leah.
Well, I don't really
Leah
like
loves
math
it.
in general.
Rachel, that's a lie.
My goodness, you guys are just saying mean things.
I like Bible. We don't do anything.
I
know he
doesn't like
You're being recorded, Alyssa Simmons.
Yeah, algebra people, let's raise your hand. Okay, raise your hand if you like algebra better than geometry.
What are you talking about? Almost everything we've done today was algebra, and you guys are crying and complaining.
It's fascinating.
Oh, you like it? It's good stuff. It's fun, fun, fun.
No, it's not.
It
That's why
is.
you're a math teacher,
It's
not
boring, boring, boring.
What are you talking about? Getting these cool answers and trying to solve for missing stuff?
Did you know Justin Bieber loves geometry?
Justin Bieber's dumb. He's not even in geometry.
Oh man.
He's an algebra.
All right, here we go. Let the fun begin. All right, here we go. Let's do this. Let's start here again. All right, this is a geometric mean, isn't it? Tell you what. Let's color code them. And now we'll use the same color for all three. Okay, so those are my geometric means. Agreed?
Yeah.
All right. I'll go back to blue to solve the problems though. So let's do this. Now look, I already know what this is. It's still a geometric mean, but it's a geometric mean between what two numbers? 3 square root of 2 and z. Right, between the two segments, okay? So what do? We set up a little ratio or a little proportion. The square root of 2 is my geometric mean, so that's going to show up in both places. Between what? Between this and this. Doesn't matter what order you put it in. There we go. Everybody see that? That's not hard. And now, that's the only geometry. That's all the geometry there is. You guys love algebra so much, the rest is all algebra. That's all it is. Okay? Look. I don't care.
I don't.
I love this baby.
Watch. Look, 3 square root of 2 times z. You can vote all you want, but I don't care. I don't care what you vote on. We're still doing it. We're still going to learn it. Look, 3 square root of 2 times z, and then multiply these. Do that in your head. What's square root of 2 times square root of 2?
Square root of 4, which is 2.
Yeah, just say 2. You don't even have to go that way, do you? You can just say it's 2.
Where are they going?
Okay, going to Pencader. So watch, divide by 3 square root of 2, divide by 3 square root of 2. Now look, we're not finished though. Do you remember in algebra? They don't like you having a square root in the denominator. There's a little rule for that. Do you remember the rule?
Square both sides.
Well, it's not both sides technically. What you do is you multiply the bottom by square root of 2 and you multiply the top by the square root of 2. Look, I did this in a different color because I want it to stand out to you. What is anything divided by itself?
1.
It's a 1. So I can multiply anything by a 1 and not change the value. Matt, pay attention. I can multiply anything by a 1 and not change the value of it. Would you agree? So, but why did I pick square root of 2 over 2? Is that like out of the blue? No, because I wanted to get rid of this square root. We've done this this is like the 3rd time now. What's a square root times itself? It's just the number inside that square root, isn't it? So if I take this and multiply it by itself, I get rid of the square root. So it's just a 2, which eventually, let's see, let's change back to blue. So let's see what we get. We get 2 square root of 2 over what? 3 times 2 is 6. All right, keep reducing. 2 goes into that once, it goes into that 3 times. Look at our answer. It's the square root of 2 over 3. Okay, it's reduced, it's simplified, and it's exact. No approximations.
Oh, I see.
That's what z is equal to. All right? Yes.
If we put the 2 square root of 2 over 6 back in 1.
It's not reduced. I want them simplified. I want them reduced. So, yes, I want them reduced. Because, look, you're working out a problem and you get like 4 over 2. You're going to circle that and leave that as your answer?
No.
No, not unless they're asking for a ratio. You're always going to simplify that, aren't you? So, if this was 2 squared to 2 over 6, it's not simplified. Okay, always simplify your fractions. All right. Let's do x now. Move it up a little bit. Let's see, what haven't we used in a while? Let's use this gray. White triangle in the
Yeah,
corner.
look at the colors on the bottom.
Oh, these, they're all the same colors up here. I don't know. Look, if they call them global, whatever. See, there's deep sea blue and there's global. I don't even know what the difference between the two is. What, that one? You won't even be able to see. I don't know. I guess you can see that. Can you see that all right? Okay, we'll use that one. I don't know what the difference is. I don't know. Let's do this. Come on, we're running out of time. I want to solve for x. So x is a geometric mean, isn't it? All these things in yellow are geometric means. So x is a geometric mean. It goes here and here. Between what and what?
The whole thing.
The whole thing. What's the whole thing?
3 squared root 2 plus
3 squared of 2 plus
z.
z. Right. That's the whole thing. So this side is a geometric mean between the whole thing and the side that's next to x. What is that?
3 squared root 2.
3 squared of 2. So you put that right there.
Z, can't we just put 2 square root of 2 over 3? We already solved that.
We didn't solve for z.
Yeah, we did.
Oh, I'm sorry. I lied. Yeah. We did. What is it? Square root of 2 over 3. Absolutely. How did I completely forget about that? So let's actually do this. Let's actually figure out what that is. So off to the side, I can't see that blue very well, so let's go to orange. Did I click it? Nope. Let's go to this orange. Okay. Let's add those up and see what we get for that whole entire thing. So it's just a matter of adding a couple things. Oops, sorry. I don't know what I'm doing. It's 3 square root of 2 plus what?
2
No, square root of 2 over 3. Right? So I'm adding them up. What do I do when I add things together? Find a common denominator. So what's that going to be? Times 3, which is what? 9 square root of 2 plus square root of 2. What does that give me? So what's that whole entire length from here to here? Come on, 9 square root of 2 plus 1 square root of 2. What's 9 plus 1?
10.
Goodness gracious. 10 square root of 2 over what? 3. So that is that whole distance. So let's do that. So what's this? It's 10 square root of 2 over 3. Now, is there a little extra work on some of these? Absolutely. But that's all right. I got nothing against a little extra work, do you? You shouldn't. So look, let's cross multiply. X squared equals, multiply these together. That's 10 square root of 2 over 3 times 3 square root of 2, just over 1. Okay? You see that? Because we're multiplying those two things together right there. We'll just keep this x squared for a second. Let's multiply these together, see what we get. So it's 10 times 3, which is 30. See if we can do this in our head. 10 times 3, actually, let's do this. That 3 will cancel out with that 3. Make it a little easier. Square root of 2 times square root of 2 off the top of your head is what?
What? 2.
It's 2. Times 10 is
20.
20.
Plus 1.
Okay? No plus 1. Look, square root both sides. You should be able to do this in your head. If you can't, let's split it up.
It's 2 square root of 5.
Very good. So it's the same as 4 times 5, isn't it? Right? Are you getting used to this now? And what is it? It's 2. Take the square root of that, which is 2, and then the square root of 5, and that's what x is right there. So there's all three of them. Where was
Y.
y?
We didn't do it.
Oh, we didn't do y yet. What are we waiting for? Let's do it. Is that green going to be too dark? Can you read that green? You can read it all right? Okay, let's do this dark green. Okay, y. Y is the geometric mean. Let's try to slide it in here. I might scooch it down after I write it out, but I want to see my picture. Okay, watch. Y is the geometric mean. Goes here and here. Between what and what?
Z and...
Between the whole thing and z. Right. So what was the whole thing? We already found that. It's 10 square root of 2 over 3. And what's the side that's next to y?
Square root of 2.
Square root of 2
Hey, they can cancel.
over 3. No. Don't be too quick to say that. Look, let's just grab this stuff. Oops. Don't want that 3. Let's do this. Let's do this. Okay. Not magical? See, that's something cool I could never do on the whiteboard. Whoops. I'll just leave it right. Okay, so y squared equals, multiply these together. So it's 10 square root of 2 over 3 times what? Square root of 2 over 3. Yeah? I'm going to keep this y squared until I figure out what this is. Nothing cancels here, though, does it? But I can do this. What's the square root of 2 times square root of 2 for like the 5th time today? It's 2. 2 times 20 is, or sorry, I gave it away. 2 times 10 is 20 over what?
9, 3.
How about 9? This is multiplication. It's multiplication. 3 times 3 is 9. So what do we do now? We take the square root. Look, we already did square root of 20 in the other one. What was that?
2 square root
It's
of
2 square root of 5, right? What's the square root of 9? That's what y is right there. Okay? That's all there is to it.
Can't wait for this test.
Look, the geometry was easy. Well, look, you're saying that sarcastically, but you should be able to do this stuff, okay? The geometry was easy. Look, this is the geometric mean between these two, right? Y is the geometric mean between the whole thing and that. X is the geometric mean between what? The whole thing and that. Your geometry is over. For all you geometry haters, okay, your geometry is over. That's it. The rest is all algebra, right? It's just cross-multiplying and then simplifying. Listen, it's all cross-multiplying and simplifying after that. That's all it is. So really, the hardest part of this whole entire lesson is not really the geometry, okay? It's just making sure that you simplify everything into the form it's supposed to be. All right, I've done plenty today for you. All right, now you're going to do some stuff for me. So I'm going to give you a worksheet. I have to go make a couple extra copies because I didn't make enough first period. So it's a worksheet and it's section 8.1. There are 2 sides to it. And now you can omit, leave out the parts. I don't know what they are off the top of my head, but leave off the parts that say... it's the part you can skip. Write a similarity statement. So if it says write a similarity statement, okay, you don't have to do those. So basically, you're just doing the stuff that I've been doing today in class. All right? Now, I'm going to let you hang on to it. Now, listen, for the problems that you couldn't do, right, before you came in today, I want you to fix those. All right? Go back, fix those on the homework I gave you last night, and then work on this worksheet. All right, I already did 2 of them for you, 3 of them actually for you today in class. Right. Well, I explained that. If you would have gone through the,
all the notes, and I was doing like as I went through the notes, like I look at the side.
I mean, I really didn't give you anything new today than what I talked about yesterday. I mean, we just did it again, and I understand. I mean, just because I say something one time doesn't mean everybody gets it. I understand that. I get that, but you could watch it over and over again if you wanted to, couldn't you? You could have done some research. You could have gone to Khan and see if he does any of that kind of stuff. See, there's all kinds of things that you could have done if you really, really wanted to learn this stuff. Agreed? You got to agree with me there. The point is, the difference is, right, if you really, really wanted to learn this stuff. That's the difference. Okay? If you really wanted to learn it, you could learn it. I promise you. Okay, enough of that.